Number 13. In an aqueous solution, nitrous acid will form an equilibrium as shown in the equation below. So our Ka expression for this weak acid is this, H plus times NO2 minus, the concentration of, divided by the concentration of our weak acid, HNO2. And the Ka is equal to 4 times 10 to the minus 4. B is asking you to calculate the pH of a buffer made by adding 0.12 moles of nitrous acid as well as 0.39 moles of sodium nitrite, which is NaNO2, to a liter of water. So I drew a little picture here to show what's going on. Into our buffer we've got 1 liter of water, and I'm putting 0.2 moles of our weak acid and 0.39 moles of our NO2, and these molecules in here are not quite to scale. And then I've got some H plus floating around because my acid will dissociate into H plus. So I've got some of those floating around. That will also produce some NO2 minus, and we're also putting in some NO2 minus. So in order to know what the pH is of this buffer, we will need to calculate how much H plus is in solution, because the H plus amount tells us what the pH is. pH is a measure of H plus concentration in solution. So this is what we're solving for, so I will represent that as X. NO2, we put in 0.39 moles. Into a liter of water. So we'll assume that the volume is 1 liter. So that means that this is 0.39 molar. And for HNO2, the same thing. We put in 0.12 moles into 1 liter. So the molarity of this is 0.12 molar. From here, we can use our Ka expression to calculate the moles, the molarity of H plus at equilibrium. Like so. So we will multiply by 0.12 and then we'll also divide by our 0.39 molar. And the concentration of our H plus is 1.23 times 10 to the negative 4 molar. That's our H plus concentration. And to calculate the pH, we'll take the negative log of this number. So take the negative log of our H plus. And if you take the negative log of it, you will get a pH of 3.9.